This is something that I wanted to bring forward really fundamentally in the climate issue. We can look at CO2 as an emission issue from automobiles, transportation, and energy in general, burning coal, burning natural gas in power plants, that kind of thing produces CO2. But there are other industrial sources of CO2 as well as methane, but for the most part, the methane gets consumed. It's either burned or it's converted into something else. And the two biggest CO2, well, I can't think of any industrial process that involves heat and doing some chemistry that doesn't kick off CO2. I mean, steel making, you name the process, it seems like CO2 is always a byproduct. It's certainly a byproduct whenever you're burning any fuel. But the biggest source, one of the biggest industrial sources of CO2 that people don't think about is cement. I'm talking about, standard cement production. Because what is cement? Well, okay, the raw material for cement, they take limestone, which is the very thing that I'm trying to produce and put on the ocean floor is the calcium carbonate lime. That is from ancient oceans in the Earth's geologic past. There are limestone deposits, which are very pure calcium carbonate, precipitated millions of years ago in a bedrock type called limestone, which is almost 95% calcium carbonate. They take that as a raw material, and one of the things that they do is calcium, cation, and then carbonate, which is carbon and 3 oxygens. What they do is it's called calcining. They heat it. They bake the limestone. They drive off CO2, and they're left with CaO, calcium oxide. What is calcium oxide? It's better known as Portland. It's cement. So in the production of any kind of cement, any kind of concrete, you're producing lime, and you're talking about tonnages. I mean, you've picked up a Sackcrete bag, right? And it's a combination. Portland's a combination, or concrete is a combination of Portland, calcium. They throw some other things in there for stabilizing, but it's basically calcium oxygen. And then they mix it with sand or aggregate. And that's your concrete or your cement. And in the production of that calcium oxide, it's coming from calcium carbonate. And in the process of doing that, they're driving off CO2. So this company that does have the processes for making this carbon sequestration technique, they're testing it right now, not on a power plant. Their original plan was to test it on a power plant. They're doing it right now on a cement plant in San Antonio, Texas. They're looking at, in fact, one of the problems they were having originally when they tried to do it on a power plant is that in addition to carbon dioxide production from burning the fuel, you also have water. You produce water. You burn a fuel, you produce water and CO2. That's the bottom line. I mean, we even do that. We burn sugar, we exhale water and CO2. Cars do that. Everything does that. Well, in a power plant, they were having problems with the water in the exhaust, if you will, or in the flue stream, getting in the way of the process. They're trying to figure out a way to perfect that, to make it work in a more general environment. But in the meantime, they moved over to a cement plant because that's just CO2 emission. They heat up the calcium carbonate, and they produce calcium oxide, and they drive off CO2. So cement plants produce tons of CO2. And another huge operation that produces CO2 is the production of ammonia fertilizer. And this is absolutely critical that the general public understand this in terms of sustainability. I always recommend this article, and I think the whole world should read it. It's called The Oil We Eat by Richard Manning. He's an ecology professor, and he wrote this article back at the time of the Bush Gulf War II, Roman II. He wrote Tracing the Food Chain Back to Iraq, and he was talking about the oil production that methane, which is natural gas, byproduct of oil production, but also natural gas is sometimes sought just on its own. Anyway, that natural gas goes into a series of plants along the Mississippi River, primarily in this country, but elsewhere, performing the Haber Bosch process. And the Haber Bosch process takes methane, CH4, plus nitrogen out of the Earth's atmosphere and produces NH3, which is ammonia. And ammonia is fertilizer. So in the production of fertilizer, now the process of that, it's actually basically think CH4 and replace the C with N. Get the carbon out of the molecule, put nitrogen in there instead. So you're producing NH3 or NH4 as ammonium, and you're driving off CO2. And it's called the steam reforming process of the Haber Bosch process. It takes high temperature and pressure to do it. So first they're using a tremendous amount of energy, heat, and pressure, and then on top of that, they're using natural gas as an ingredient to produce ammonia, and at the same time liberate CO2. So you have CO2 production coming out. And I think Richard Manning says 40% of the world's population eats only because of the production of ammonia. It's that critical of a fertilizer in industrial agriculture. And 40% of the world's population depends on this ammonia production from these Haber Bosch plants, and they're CO2 emitters. They consume methane, which is a good thing, but they produce CO2 as a result. So anyway, I could imagine that this process that I'm talking about of trying to capture the CO2 out of the flue stack could be applied to these plants as well. So you get cement plants, the Haber Bosch ammonia production plants, and just about any process that liberates CO2 could take advantage of this process.
Right.